All right, hello everybody, and welcome to the Vector Addition Lab. So this is what we call a force table. This is the apparatus we'll be using in today's lab. And basically it has from 0 to 360 degrees, so we can actually pinpoint where we're going to apply these different forces. So let's get started. What does that actually mean? So just starting, we have some strings attached to a hook with a bead in the middle or a bar in the middle. And then we have some pulleys that we can attach to the side of the table, right? And so this just slides onto the table like that, and it's got this camber here to lock it in. And so that would just be like to slide it on and then lock it in. Now, if you look, there's a little notch right there. That little notch represents exactly where this wheel is, so that tells you exactly what angle from 0 that is being applied. So a force, we discussed forces in class, right? And what is a force? A force has a magnitude and a direction. And so we're doing this experimentally. We have direction and we have a magnitude. A magnitude is given by the actual weight. So in this case, I'm going to put this 100-gram mass onto the mass hanger, and I'm just going to hang it off the side over here. So where would I need to put another mass and this other pulley to make this equal, to make it equal out? Well, we know instinctively it's almost just like thinking about tug of war. Well, if this guy's pulling this way, then we need to have one pulling the exact opposite direction with the same force. So let's move this wheel over here to 0. Because this one's at 180, so we know that that's a straight line, 180 degrees. And I know if this one I put a 100-gram mass on the end, then on this side I would need to do the same thing. So I'll put a 100-gram mass on the mass hanger, I will attach it to this string, and I will hang it off the end of here. And so now these two are equal and opposite. So make sure your strings are also equal and opposite on this ring, because if I have the string way over here on this side, it's going to be like pulling at an angle, and that will make a huge difference. But right now we can see that if I set that even, then that's even, which is what we'd expect to see. We have a 100-gram mass hanging on this side, a 100-gram mass hanging on that side. So our force is what? Our force is 0 degrees, 100 grams, and 180 degrees at 100 grams. They're equal and opposite. Now, this force that I put on originally was just some force we applied. This force, to make this equal out, is called the equilibriant force. In other words, it equals the result force of this side. Now, why do we call this side the result? Because we can actually add more than one forces at a time to this situation. And so let's think about that for a minute. I'm going to take this 180 degrees and I'm going to move it over to, let's say, 145. Well, now we know that this is out of balance, right? You can see the ring is pulling on the edge of the thing. And we can see, where it wants to hang if we take it off. But we don't want it. We want it to be equal here. So what do we need to do? We need to add another force somewhere over here, right, to pull it back this way. So let's go ahead and do that. Let's take another mass hanger. We have another string here. Okay, so that alone is not enough. Let's go ahead and add 100 and see what happens. Well, now it's pulled like over here a little bit. Let's make sure this string is nice and centrally located. Well, that's pulling too much, right? So what do we need to do? We need to still get it to come this way. So if I roll it around, so somewhere right in here seems to be the magic spot, right? But we still see that it's not enough weight, so we need to add a little more mass to this side. So let's go ahead and add a 20. Oh, that's too much. Let's go ahead and add a 10. Ah, that looks very good. So now what are we talking about here? What's actually happening? This force didn't change, did it? This force stayed the same, in the same position, everything is still the same. Which means that this force thinks that that force that we had at 180 degrees is still there. It doesn't realize that we've moved everything around. It thinks that there's just one force over here at 180 degrees that's equal and opposite of what it is. Does that make sense? I hope that makes sense. And what we call that is still the resultant. This is the equilibriant. This equals both of these added together in that direction, which means the resultant force, or the result of adding these two together, is that force that we had a minute ago that was hanging off here. And so if you were to take this and you were to actually add the cosine of that and the cosine of this, you would find that this force would be at 180 degrees and it would equal the same magnitude as this, which was, I think, 100 grams that we had on there. All right, so this is how it works. Today you'll have to do this a couple of times. We're going to have one where you have two, and then there's going to be another one where we actually add a third over here somewhere. And so you're going to have three vectors or three forces pulling in this direction, and then you're going to have to figure out how you counteract that in that direction, what angle it has to be at, and you can figure all the components out. You'll do this experimentally like this, and then you'll do it mathematically, and you'll figure out what your percent error is between your experimental and your theoretical. Okay. With that being said, I think that's a good enough explanation for today's lab, and I will see you in the lab. Bye for now.